This is Math 261, Section 11.4 on the cross product, and this is Part 8. And in this example 5, we need to end up finding a unit vector that is orthogonal to u and v. We'll do this in 2 steps. To start, we'll find the cross product. And the reason we find the cross product to start is we know that the cross product u cross v is orthogonal to u and it's orthogonal to v. So I've set up the grid for the cross product here. I'm going to jump right into it, writing out the terms. So first of all, we'll have 6i, and then we'll have 4 times 17. 4 times 17 is the 68j. And then from the third diagonal, k times -8 times -18 is 144. And then we have minus the diagonals going the other way. And so there, for the first of those, I have k times -6 times 17 is -102. And then the next one is I times 4 times -18. 4 times -18 is -72. And lastly is j times -8 times -1. And we have 6i plus 68j plus 100. Oh, hang on just a second. This wouldn't be j and j. Second diagonal had the k. Or the hang on. Right here should be k, because that would come from here times here times here. Now we need to combine like terms. 6i plus 72i would be 78i. 68j minus 8j is 60j. 144 plus 102 is 246k. So that's the cross product. U cross v. And that's good because that particular vector, this guy, 78i plus 60j plus 246k, is orthogonal to both u and v. That's half the battle. That's step 1, start. Step 2 is to find a unit vector, and that means length 1. And that's from a previous section. What we need to do is find the magnitude of this vector. (78, 60, 246), and then divide the vector by its magnitude, and that's called normalizing the vector. This turns out to be the square root of 70,200, and 70,200 is 900, which is a perfect square, times 78. So 30 radical 78 is the exact simplified radical form of the length of this vector. And then to normalize a vector means to take the vector 78, 60, 246, and divide the vector by the number 30 radical 78, its magnitude. And to divide a vector by its number means each coordinate should be divided by the number, like so. And then I simplified each of those coordinates to this answer. So this vector is orthogonal to both u and v, the given vectors, and this vector also has length 1. And just a little quick couple comments. If you're curious how I got this right here, it's it's a little bit trial and error, but I mean, you can go about it kind of efficiently. I figured that 4 went in. It looked like 4 would go into that, so I divided 4 into that. And then I took, and then I recognized that 25 would go into this because it ends in 50. So I divided 25 in. I got 702. And I know if the digits add up to a number divisible by 3, then 3 will go in. So I knew that 3 went into 702. I wasn't sure if 9 went in, but I figured it was worth a try. So I tried 9, and I got 78. And the point is that these 3 numbers are all perfect squares that go into the original thing now. And so I multiplied them together. So I know the original was the product, 900 times 78 now. And I thought a little bit more about 78, if any perfect square went into that, and nothing does, so that was that. The other real quick comment here is way earlier in this series of notes on the cross product, there was one of them where I did the calculations a little bit differently. It actually goes back to how I learned this in 1987. I was right here. I mean, it turns out the same way, but I just don't want you, if you caught this, you probably looked at this a while ago if you're going through these. This was part 4, this example, J cross I. And all it is that right here, I put a plus sign. Whoops. Put a plus sign. And then I put negatives in front of the terms inside the parentheses. And that's not how this formula is set up. Because this formula, and this formula I think is superior to the way that I learned to do it. So I like this formula. But sometimes I revert. These guys all have plus, and then there's a minus, and then these guys in the parentheses. And then you just work it out like I did, I think, for all the other ones. So just don't be kind of thrown off by that one example.